Man's adaptability has enabled him to exploit most of the habitats that the world has to offer. His intelligence and dexterity have created the highly specialized environment in which he lives. Such is man's achievement that a comparison between him and other animals is often thought to be invalid and unacceptable. Yet it's a fact that man is an animal, a mammal, a member of the class of creatures who bear live young and who suckle them from their mammary glands. Mammals are one of the most diverse groups of animals. In this group are the bats and bears, seals and armadillos, giraffes, pandas, dogs, goats, cows, whales and dolphins. All of them produce their young live and feed them with the milk secreted from their mammary glands. With such a diversity of form and lifestyle, it would be surprising if mammalian milks were all the same. In fact, they differ widely, and the differences clearly relate to physiological needs and environmental influence. The young bear, for example, is born in the middle of winter when its mother will be deep in hibernation. The young seal in an environment in which the temperature may be many degrees below zero. The brown bear cub develops quite slowly and becomes active only when its mother is aroused from her winter sleep. The seal pup is known to swim within a few weeks of birth. Seal milk contains a very high proportion of fat to ensure rapid growth of a protective layer of blubber that insulates the young seal from the Arctic temperatures in which it lives. Each type of mammalian milk contains a balance of fats, carbohydrates, proteins, minerals, and vitamins in proportions that are tailored to the physiological needs of the young. Fats occur in milk as oils, which contain substances called fatty acids. The fats are broken up into tiny droplets. Fats are an excellent source of energy, and excess fat is stored in the body as an energy reserve. Proteins are an essential part of every living cell and an indispensable part of every diet. Protein molecules are complex chains of simple compounds known as amino acids, which are the building blocks of most body tissues. Carbohydrates are the primary source of energy for the growing organism, and they are one of the most important constituents of any mammalian diet. Commonly occurring carbohydrates are the sugars and starches. Vitamins and minerals play a vital part in the many chemical reactions that constitute metabolism. There are, of course, similarities between the various mammalian milks, but there are also significant differences in the proportion and kind of ingredients which relate directly to the special needs of the young. Thus, for optimum growth and healthy development, there is no naturally existing substitute for mother's milk. Man, because of his superior intelligence, has been able to domesticate a number of other species and to utilize them as sources of food. Perhaps the most striking example is the domestication of wild cattle, which, by a careful process of selective interbreeding, has produced the domestic cow. Indeed, the cow is not only the most obvious, but also the most interesting example, because it provides not only a source of meat, but also milk, an abundant but highly perishable natural food. A vast technology has been created to make milk more widely available as a food for man. Milk and dairy products exist in enormous variety. Graded and processed in many different ways, milk has been pasteurized, homogenized, evaporated, acidified, skimmed, condensed, freeze-dried, and powdered. It is available in bottles, cartons, and cans. It has been flavored in a dozen different ways. Perhaps no other basic food has been given so much attention and presented in such variety. One of the results of man's ever-increasing sophistry is a change in the lifestyle of many women. Increasingly, mothers choose or need to work outside the home. And in these circumstances, the natural regimen of breastfeeding is inconvenient, if not impossible. Additionally, there are, of course, women who temperamentally, constitutionally, or through poor health, produce an inadequate supply of milk, or one which is deficient in dietary requirements. So it is entirely logical that man should have turned to cow's milk for use in feeding his own young. But no matter how advanced the technical process employed, whole cow's milk can never be an ideal substitute for human milk. Cow's milk is specific to the needs of a calf. The proportions of fats, proteins, carbohydrates, vitamins, and minerals differ from those found in human milk. As you can see, cow's milk contains less lactose, or milk sugar, an important carbohydrate. It has more protein and approximately the same level of fat, but more calcium and phosphorus. The only way to produce an ideal substitute for mother's milk is to create one, ensuring that each of the nutrients resembles as closely as possible those in the milk of the healthy nursing mother, and is present in the same proportions. This close approximation to mother's milk is precisely what happens in the manufacture of Similac. Let's have a brief look at the Similac formula, compared with breast and cow's milk. Lactose is one of the primary sources of energy for the growing child. Because cow's milk, unlike Similac, contains less lactose than human milk, some of the protein in cow's milk has to be used up as an energy source. Protein levels in Similac and human milk are comparable, and in that protein are the 9 amino acids essential for the growth of an infant, and they are present in exactly the same proportions as in breast milk. There are a higher proportion of utilizable fatty acids in human milk and Similac than in cow's milk. Cow's milk has more calcium and phosphorus, and their ratio differs from that of Similac or human milk. Cow's milk also contains less vitamin A, D, C, and E. It is pretty obvious that while cow's milk is ideal for calves, it is not the best source of nutrition for growing children. Now let's look in greater detail at Similac, a product that has been made to measure so that it provides optimum nutrition for the human baby. Because Similac contains the same quantity of lactose as human milk, the acidity of the child's stool is maintained and the risk of perianal dermatitis reduced. Lactose enhances calcium absorption, and that is very important for the production of healthy bones and teeth. Because lactose is less sweet than sucrose or other sugars, the baby fed Similac is unlikely to refuse breastfeeding when Similac is used to supplement the breast. The energy contributed by the lactose in Similac is identical to that in human milk, thus making available the optimum amount of protein for sound growth. Similac protein is soluble and forms a fine fluid curd, similar to that of breast milk. It's easy for a young child to digest. Similac fat is also very easily digested because it is doubly homogenized so that the fat particles are very small. Similac fat is a blend of corn and coconut oils, which yield easily assimilated fatty acids. Because the butterfat of cow's milk is absent, gastric upset and abnormal stooling are minimized, and sour spit-up odor is eliminated. The fat in Similac contains a high proportion of a substance called linoleic acid, which helps to protect baby skin against dermatitis. Similac contains all the known essential vitamins in quantities that closely resemble those in breast milk, so Similac-fed babies are protected against diseases like xerophthalmia, beriberi, scurvy, rickets, and other deficiency diseases. Doctors know that babies fed Similac are getting the right vitamins in the right proportions. And the mother, of course, does not have any added cost or inconvenience from using vitamin supplements. There are normal waste products from every food, and they are removed from the body by excretion. Water is vital to excretion of waste by the kidneys. Similac, like breast milk, requires only a small proportion of renal water to eliminate waste products, so that baby retains an adequate water reserve to meet other stresses. Babies are particularly prone to dehydration, so it is important that excretion uses up a minimum amount of water. Because young babies grow very rapidly, especially during their first 2 years of life, they tend to need relatively large amounts of iron, particularly in building up new blood supplies. This can result in iron deficiency. It is therefore important to maintain a correct iron balance during the first 18 months of life, and this can be achieved by assuring that the proper amount of iron is available in the diet. Similac with iron provides 12 milligrams of ferrous iron per litre to maintain iron stores during the first year in term and premature infants. When fed throughout the first year, it also ensures adequate iron reserves in second year of baby's life and gives significant protection against anemia. Similac is an ideal infant formula because it is specifically built for the needs of the growing child. In every important respect, it simulates breast milk, eliminating many common feeding problems. It is uniform, easy to use, and convenient, a compatible supplement to breast milk and suitable for feeding from birth to weaning. Similac preparation is very simple. In hospitals, formula room personnel have no need to order, stock, measure, or mix ingredients. For mother at home, only water has to be added. Similac can be prepared in single feedings as needed or in larger amounts for the whole day. Because the addition of other ingredients is completely unnecessary, the risk of adding harmful substances is minimized. The human baby is fortunate. The offspring of other mammals must, in their first days of life, be fed from their mother if they are to survive. For baby, there is Similac, the formula which ideally approximates mother's milk because it is made to measure.